Hello guys, how are you doing? This is Mahyar. In this video, we're going to talk about architecture section in details, especially concurrent statement. And I have a good news for you. After this video, we will start a playlist where we upload example videos showing hardware implementation using Vivado. If you want to learn Vivado as well, don't forget to install that software. And before we continue, don't forget to like and subscribe this channel so you won't miss the upcoming videos. As you can see in the picture, the structure of architecture section is like this. First, give your architecture a name and link it to an entity. Next is the declarative section, where you define signals, constant, aliases, types and subtypes, component, and attributes. And after that, there is a begin word which separates your architecture section into second part where you can write your concurrent statement. And at the end, you need to close your architecture section using an end command. As I said, in declarative part, you can define your signals, but what's a signal and what is it used for? Let's learn this part with simple examples. A signal is an element used for various purposes like wiring, flip-flop, register, and sometimes even memory. If you want to define a signal, first you need to write the word signal and then name of your signal and then semicolon and then you have to specify your signal type. In this example, the signal A is defined first and then used as a wire to connect two logic gates in the concurrent section. A signal can act as a D flip-flop as well, storing data at each rising or falling edge of the clock. As you can see in this example, a signal called A is defined in this line, and then in the concurrent statement, data B is stored in it. And if you define a signal as a vector, it can be used as a register. Now we got to constant declarations. Here you can see two simple examples of using constant values. In the first one, two constant values called A and B are defined in these lines, and then value of 8 and B are stored in them. And later in the assignment, their values are added together and stored in a signal called C. In the second example, as you can see, the constants are used inside the loop statement. In declarative part, you can use aliases too. You use aliases to separate your large data into several pieces to use them separately in different operations. In this example, a 7-bit data is defined as A and its first 12 bits are defined as data and the next 4 bits represent as address and its last bit is used as a flag. If you want to separate these bits, you have to use aliases command like these lines. After defining these aliases, wherever you use B, C or flag as a value, the value will be pointed to the value we pointed before. And keep in mind, whenever your 7-bit of data change, the value of B, C, and flag will automatically change as well. Now let's talk about type and subtype. As you can see in this example, a type called A is defined and the value that this type can hold is red, yellow, green, blue, and orange. And after that, a signal called B is defined as this type and its default value is being set as red. This type and subtypes are widely used in VHDL, especially for designing state machines. As you can see in the second example, a type called a state machine is defined and can hold a value of A, B, C, D, and E. And then a signal which its type is state machine is defined with the default value of A in it. And that's it. We talk about all declarations with example except the last two, which is component declarations and attributes, which we will talk about them in upcoming videos. Now let's talk about concurrent statements. In this part, you can write signal assignments, conditional and selected statements, generator statements, block statements, components, and process statements. Let's see them how they work in examples. Signal assignments are used when you want to change a parameter's value. For example, in the first line, the value of B is assigned to A, meaning a parameter called A will always hold a value of B. In the second example, the output of logic and operation of B and C is assigned to A, and that parameter will always hold that logic operation's output. In the third line, the 6th bit of B data is assigned to A, In this case, B parameter holds more than 1 bit of data, but A parameter only holds 1 bit of data. Now let's see how to use logic statements in VHDL. As you can see in the table, it's really easy. You just have to put a statement between the inputs. The only exception is not operation, which you should write it like this. After that, we go to conditional and selected statements. A conditional statement works like a three-state buffer, determine which value is assigned to an output based on the condition. In this example, C is a conditional signal, and when it holds logic 1 as its value, A will be assigned to D, and when in otherwise, B will be assigned into D. And a selected statement functions like a multiplexer, when an output value determines which signal is assigned to an output. In this example, the value of E specifies whether A, B, C, or D should be assigned to the output. Now we got to generate statement. A generate statement acts like a loop, but it's used in concurrent section. Note that we also have a regular loop which can be used in a process as a sequential statement, and we will talk about them later. But here we have a generate statement, which is a concurrent statement and it should be used outside the process statement. As you can see in this example, a generate statement is used whenever you have a similar assignment and you want to simplify your code. And the last one is block statement. A block statement lets you divide the concurrent section into independent blocks with no direct connections. In each block, you have declarative part and concurrent part like an architecture. It's like you have multiple architecture inside one architecture. Imagine a time when your module don't act as you wish in the test bench. In this situation, you know exactly where you should look for a bug in your code. So a block statement will be used to increase your code's readability and helps you for debugging. And we talk about all concurrent statements except the component and process statement, which we will talk about them in episode 4 and episode 5 of our playlist. Thanks for watching. If you find this video useful, please share it with your friends and don't forget to like and subscribe this channel for upcoming videos. And don't forget to leave your thoughts in the comments. Till the next video, take care.